Hello students, let us do the analysis of propped cantilever beam by slope deflection method. Based on the results, we can draw the bending moment and shear force diagram. So you can see a propped cantilever beam which is fixed at A and simply supported at B. It is provided with UDL and span length of the beam is L. So propped cantilever means you can see the end A is fixed. So there won't be any displacement. Theta A 0 and B is hinged, it will allow rotation, so theta B cannot be equal to 0. And next we are finding the fixed end moments. To solve the slope deflection method, we need two set of moments. One is fixed end moment, the other one is moment due to the joint displacement. So let us find the fixed end moment. If the span is with complete UDL, then we can take the left side moment is minus WL square by 12. Right side of the span you can take plus WL square by 12. And after finding the fixed end moments, you just add the fixed moment with the moment due to the joint displacement. So this MAB equal to FAB followed by 2EA by L 2 theta A plus theta B. The second component is moment due to the joint displacement, which is written as 2 in the form of 2A by L bracket open 2 theta near end plus 2 plus theta far end. So in MAB, theta A is near end and theta B is far end. So you substitute and the equation 1 is uptime. Theta A is equal to 0, so it gets cancelled. Similarly, MBA, WL square by 12, 4EA by L theta B. So after obtaining these two equations, we have to solve that equation. Theta B is unknown. So we need only one unknown, we need only one condition. We can take any conditions like joint displacement conditions, compatibility equations or end moment equations, something. So for solving this theta B unknown, we are taking MBA equal to 0. So we are equating equation number 2 to 0, WL square by 12 plus 4EA by L theta B equal to 0. So from that we are getting EI theta B minus WL, that is going to be minus WL cube by 48 EI. This negative sign indicates the rotation is anti-clockwise. So substituting this value in equation 1 and 2, we can get the end moments. After obtaining theta B, we are getting the end moments. MAB equal to minus WL square by 12, 2A by L, A by L, EA gets cancelled. So remaining, you simplify, you can get minus WL square by 8. Negative sign indicates anti-clockwise. And MBA equal to moment is you substitute theta B, you can get the moment 0. So MBA is 0 because it is a hinged end. So now we have to plot the free body diagram. From that you find the reaction and shear force based on the equations of equilibrium. So let us consider the free body diagram of this beam to find the reaction. We mention all the moments we obtain, and just by equations of equilibrium we are getting RA 5 by 8 WL, RB 3 by 8 WL. Simply taking the moment at B equal summation of moment at B equal to 0, we are getting this. And now we are getting the span moment by CSS beam with UDL. So the equation is WL square by 8 and followed by joint moment due to the joint displacement WL square by 8 in the fixed NDA. So superimpose these two, you can get this diagram. Now the question is where the max will lies, where the shear force gets 0. So for finding this thing, you just equate, you take the shear force at that point, keeping the distance x, and find the x is equal to 3 by 8 L. And similarly at that point you find the maximum bending moment. The moment is going to be 9 by 28 WL square. So point of contraflexure is where the bending moment changes sign. So we have to consider the point where the bending moment gets changed. So just keep it as x distance unknown and find the x value. And also find the shear force at other points like x is equal to 0 at this end and x equal to L at the other end. You find the shear force component. And this is the final solution. Using this bending moment and shear force value, we can consider the design further. We can consider it for the designing the members. Thank you.